Welcome to CREATA classes. In this lecture, we will cover the graph of sine function in complete detail. We will see how to calculate the value of sine function from 0 degree to 360 degree, and we will see how to use this value in plotting the graph of the sine function. We will also see the feature and the behavior of sine function, that is very important. We will observe the various observations that we got from the sine function, basically the graph of the sine function. And we will link the sine function in the unit circle with the sine function in the graphical form, okay, that we will see in the course of the lecture. It will be a detailed lecture, so pay your full attention please. It will also clear all your doubt related to trigonometry. Okay, so let's begin with the lecture. Let's take our diagram of unit circle. In the previous lecture of nature of trigonometric function in different coordinate system, we have discussed the angle is written on periphery of a circle, and this angle is with respect to 0 degree, that is x-axis, and this is the standard form of writing angle on circle periphery. Same thing is done here also. Angle theta is marked with respect to x-axis and is written on periphery of the circle. In the same notation, we will write all the angles with respect to sine function, and we'll write the sine values of these angle in bracket next to the angle. Okay, this is a standard way of writing angles and their trigonometric values. Let's see what I'm actually talking about. Let's begin with 0 degree angle. We know sine 0 degree is 0, so we will write 0 in the bracket. The first 0 is 0 degree angle, and the next 0 in the bracket is sine value of that angle. Both are 0 here, not a good example. In the next angle, it will be further more clear, okay? Further moving, next specific angle as per our trigonometric table is 30 degree. So we will firstly write 30 degree on periphery of the circle, and we know sine 30 degree is 1 by 2. So we will write 1 by 2 in bracket. Okay, got it? 30 degree is angle and value in bracket is its sine value, that is sine 30 degree. Similarly, we will make angles like 45 degree, 60 degree and 90 degree, and we will write sine value of this angle as 1 by root 2, root 3 by 2 and 1. We have done this for first quadrant, means from 0 to 90 degree. We can write 1 by 2 as 0.5, 1 by root 2 as 0.7 and root 3 by 2 as 0.87. You can check the value on your calculator. Now, if you observe the value of sine function moving from 0 degree towards 90 degree, its value is increasing. Say, firstly it begins with 0, then increases to 0.5, then to 0.7, then to 0.87 and then to 1. So as a conclusion, we can say that in first quadrant, sine value increases from 0 to 1. Are you getting the point? In first quadrant, that is from 0 to 90 degrees, sine increases from 0 to 1. Okay. Let's move further to second quadrant. Angle here will be 120 degree, 135 degree, 150 degree and 180 degree. Why we have chosen these angles? Because on adding 90 degree to our specific angles of trigonometric table, we got this angle. Like 120 degree is 90 plus 30 degree, 135 degree is 90 plus 45 degree, 150 degree is 90 plus 60 degree, 180 degree is 90 plus 90 degree. Okay, got the point? These are just our standard angles, but with addition of 90 degree, as we are in second quadrant. Let's find sine value of these angles, okay? But how to find it? We will use the formula that we have derived and discussed in our previous lecture of nature of trigonometric function in different quadrants. The formula used here will be sine 90 plus theta is equal to cos theta, okay? So sine 90 plus 30 degree will be cos 30 degree, which is root 3 by 2. Sine 90 plus 45 degree will be cos 45 degree, which is 1 by root 2. Sine 90 plus 60 will be cos 60, which is 1 by 2. Sine 90 plus 90 will be cos 90, which is 0. Okay, let's solve the fraction and see the value. We see that at sine 90 degree it is 1, and as we move further, its value decreases to 0.87, then to 0.7, and then to 0.5, and it ends at 0, means sine decreases from 1 to 0. So as a conclusion, we can say that in second quadrant, sine decreases from 1 to 0. Okay, got it? Any confusion? In first quadrant, sine increases from 0 to 1, and in second quadrant, we have seen sine is decreasing from 1 to 0. Okay, let's proceed to third quadrant. In third quadrant, the angle will be 210, 225, 240 and 270 degree. Why we have chosen this angle? Same reason, that is on adding 180 degree to our specific angles of trigonometric table, we got these angles. Like 210 is 180 plus 30, 225 is 180 plus 45, 240 is 180 plus 60, 270 is 180 plus 90 degree. Okay. The formula here applicable will be sine 180 plus theta. So what is the formula? I have told you in previous lecture that 180 and 360 degree are not changing any forms. Mean sine will remain sine, so it will be sine theta only. And 180 plus theta is in third quadrant. So if we apply all school to college technique, we got in third quadrant only 10 is positive. So here sine will be negative. So our complete formula will be sine 180 plus theta is equal to minus sine theta. Okay. Let's calculate the values of our angle. Sine 180 plus 30 degree will be minus sine 30 degree, that is minus 1 by 2. Sine 180 plus 45 is minus sine 45 degree, that is minus 1 by root 2. Sine 180 plus 60 degree is minus sine 60 degree, that is minus root 3 by 2. And finally sine 180 plus 90 is minus sine 90 degree, that is minus 1. Here also on observing, we found that value of sine moves from 0 to minus 0.5, then to minus 0.7, and then to minus 0.87, and finally to minus 1. So we can say that in third quadrant, sine decreases from 0 to minus 1. Okay, got it? We have seen in first quadrant, sine increases from 0 to 1. In second quadrant, sine decreases from 1 to 0. In third quadrant, it further decreases from 0 to minus 1. Okay. Let's see its nature in fourth quadrant. The angle will be 300 degree, 315 degree, 330 degree and 360 degree. That will be 270 plus 30, 270 plus 45, 270 plus 60 and 270 plus 90 degree. Same funda applies here. The formula applicable will be sine 270 plus theta. We know at 270 degree, sine changes from sine to cos, and in fourth quadrant only cos is positive, that is all school to college, college C for college, C for cos. So our sine will be negative here. So our complete formula will be sine 270 plus theta is equal to minus cos theta. Okay. The value of sine of this angle will be minus root 3 by 2, minus 1 by root 2, minus 1 by 2 and 0. So you have observed correctly that its value is increasing from minus 1 to 0. So we can say in fourth quadrant, sine increases from minus 1 to 0. For simplicity, let's delete all the middle angles. We will be left with only major angles on axis system, that are 0, 90, 180, 270 and 360 degree. Through this, you can easily memorize that sine 0 is 0, sine 90 is 1, sine 180 degree is 0, sine 270 is minus 1 and sine 360 degree is again 0, which shows that sine increases in first quadrant from 0 to 1, then decreases in second quadrant from 1 to 0, and then again decreases from 0 to minus 1 in third quadrant, and then increases in fourth quadrant from minus 1 to 0. Okay. It has one more observation, that is second observation, that is the value of sine lies between 1 and minus 1. It never exceeds 1 and it never goes below minus 1. So we can say that maximum value of sine is 1 and the minimum value of sine is minus 1. Okay, this is our second observation. Till now we have made trigonometric table from 0 to 90 degree only. Let's complete this table for sine theta. That will be from 0 to 360 degree. Okay. We have already calculated all the values in our circular system. Let's put the value in the table. These value and the table will be useful in plotting graph of our sine function, which is topic of our lecture. Okay. Now we are having all the values of sine function and all the angle. Let's move to graph and we will try to plot the graph of sine theta. Okay. Now, how to plot the graph? What are the things that you need to plot the graph? Here we need two things to plot the graph: items on x-axis and items on y-axis. Here on x-axis, we will take all the angles like 0 degree, 90 degree, 180 degree, and this angle will continue to 360 degree. On y-axis, we will take values of sine theta, which lies between 1 and -1, as it does not exceed 1 and does not go below -1. So we will take +1 on y-axis and -1 on -y-axis. Are you able to visualize the 4 quadrant here? 0 to 90 degree is in first quadrant, 90 to 180 is second quadrant, 180 to 270 is third quadrant, 270 to 360 is fourth quadrant. Are you getting the visualization? Are you able to connect circle system with our graph system? Both are same. I'm telling this because I want to connect both the system. In circle system, everything is in rotating form. Okay. Here on graph system, it is in a straight length form. You can say that we have unrolled the circle to the straight form. Circle system is having the 4 quadrant and our graph is also divided into 4 quadrants. Are you able to connect both the systems? Let's begin with plotting of the graph. Let's take our first quadrant. We know sine 0 degree is 0. Let's mark a point at 0, 0. Sine 30 is 0.5. Let's mark a point at 0.5 again 30 degree. Now mark our next point as 0.7 against 45 degree, and further 0.87 against 60 degree, and finally 1 against 90 degree. Now we are having all the points in first quadrant. Let's join them to form a graph and see how it looks. On joining, you will observe a curved line. This is our sine graph in first quadrant. Before moving further, a small information for you. This is only a small lecture on trigonometric graph of a sine function. If you are enjoying this lecture, you will also enjoy our full-length course on trigonometry. Yes, we are having a full-length course on trigonometry using animation and the visual tools. It has 10 modules with lots of caution and assignments for practice too. This course is for school students and students preparing for any competitive exam. Concepts are raised from very basic level to the advanced level. So check the link in the description for enrolling for the course. Okay? So without taking any further time, let's continue with our lecture. You can clearly see that here sine is increasing from 0 to 1, and we know sine increases in first quadrant. Now with this, you can more connect our circle system with our graph system. Let's do the same thing in second quadrant. We know the values. Let's put the values in graph. We will got the point at 0.87, 0.7, 0.5 and 0. We have just plotted points against second quadrant angle that are 120, 135, 150 and 180 degree. Just join the points to form our sine graph in second quadrant. See, in second quadrant, sine decreases from 1 to 0. Okay. Do the same thing for third quadrant. The point will be -0.5, -0.7, -0.87 and -1. The graph here in third quadrant is decreasing from 0 to -1. In fourth quadrant, the point will be -0.87, -0.7, -0.5 and 0. Here the sine graph is increasing from -1 to 0. So this is the sine graph from 0 degree to 360 degree. This is also known as sinusoidal graph, or sometimes sine waves in physics term. It has wide application in mathematics, physics, engineering, signal processing and many things. This is very important waveform. Okay, let's observe the graph in detail. It increases in first quadrant, we know, then decreases in second and third quadrant, then again increases in fourth quadrant. Its maximum value is 1 and its minimum value is -1. Means its range is from positive 1 to negative 1. Okay, let's compare our graph system with our circle system. This will give you a better picture and understanding of the concept. The radius line in circle is rotating from 0 to 360 degree, and our sine value written in bracket against specific angles are also changing. These sine value written in brackets in circle system is same value written on y-axis in graph form, and the angle on circular system is written on x-axis. I think you have got the concept. One more thing, this graph is not limited to 360 degree only. In our lecture of degree system, we have done that in a circle, the angles are not limited to 360 degree. On further rotating the radius line, the angle crosses beyond 360 degree. Same thing is applicable here also. As we cross 360 degree, our graph again started from 0 degree and it repeats itself after every 360 degree. And we keep on increasing the angle, it will also keep on moving and it goes till infinity. Same thing is also applicable in negative angle, that is angle below 0 degree. Here the graph keep on moving but in reverse direction. In angles below 0 degree, you have to see its complementary angle in circle system. Like if we talk about minus 30 degree, we have to move minus 30 degree beyond 0 degree in circle system. We will reach to 330 degree. So 330 degree is a complementary angle to minus 30 degree and we know the value of sine 330 degree. In similar fashion, you can calculate the value of any angle beyond 360 degree also. Just you have to find its complementary angle in circle system. Let's take an example and say we have to find the value of sine 390 degree. 390 degree can be located as 360 plus 30 degree. It will lie in first quadrant, okay? So we can say that 390 degree is complementary to 30 degree angle and we know the value of sine 30 degree as 1 by 2. Okay, got the concept? Now you must be understanding the value of unit circle. You can do an experiment in your notebook. Take a graph paper, just plot the sine wave in your graph and also plot sine wave with negative angle. This will give you a clear picture of the topic. Okay, you have seen this graph is repeating itself in positive direction also and in negative direction also. So we can say the nature of the graph is periodic in nature. That is, after 360 degree, it repeats itself. So that's it for this lecture. For more information, visit our website creataclasses.com. The link is given in the description. So thank you very much for being with Creata Classes. Bye for now.